Hey, uh, hello. Today we're working on DFS BFS. It's pretty much the same as last week's presentation, but we're going to focus on BFS DFS. And the ordering is a little bit different, and I added some extra stuff. So very first thing to do is going to be to look at this problem. You can check out the original problem on LeetCode as well, but it's summarized here. And basically just think about it for maybe 5 minutes or so and think about like how you would approach this problem and what kind of things would you do if you were given this grid and you're just going to manually solve it by hand. How would you count this and things like that? So think about that and be ready to share maybe. So we'll take 5 minutes, come back at like 4:40. Okay, so the time is 4:40. So let's say you aren't allowed to use the words BFS and DFS. How would you go, how would you approach this problem? What kind of things are you thinking about? Would anyone like to share?
Maybe just DFS one by one, like
without using the word DFS.
Yeah, so on each cell you kind of have a visited grid.
Okay.
That is 2D array and that is initialized by 0, and for each cell in the grid you visit one item by one. It's kind of hard to explain without using the word DFS.
Do you want to just like draw it like red, like where do you go first? Do you start at top left or something?
So I would visit one by one. Like I will first visit right cell, and if right cell is in the visited array, then I will not visit it, and I'll look for every direction.
So you'll have a separate array that marks whether you visited it or not, and then what do you do next?
So I'll first visit the 0, 0, like
0, 0.
0, 0, and then visit the next row.
Next one.
The right column. And the right.
Keep on going right.
Yeah, keep on going and until I meet like 0. Yeah, there.
Until you hit 0.
Yeah, then I'll go previous row and
go back.
Go down. Yeah, go down and mark it visited, and then I'm out of option, so I'll go back.
You check the other
on the second column, I start visiting down.
Yeah. Okay.
Yeah.
And then so for everything, you go in a direction, keep on looking in every direction, and then if it's a 1, then you go to it and look in all directions, whether it's an island again.
Yeah, right. And if I do this for every cell, and then when I'm done visiting, like if I like colored every possible like reachable cells from that like from the cell, like select cell, then I'm done marking it and I just add Iceland variable 1.
Okay. So after doing one iteration of this, then you know that you have one island.
Yeah, right. Then after that iteration, on second iteration, I look at 0, 1. 0, 1.
0, 1.
But that is market as visited, so I ignore it.
Okay.
Like the kind of loss.
And then these surrounding ones, maybe the second example is better. So let's say you've checked this, right?
Yeah.
And then
that is on the first iteration after I visited like 0, 0
first iteration, you've done this, right?
Yeah, and then I look through all the cells, like just iterating using like ordinary 2D loop.
Okay.
Then I'll like not start the search after I made that one.
Until you find, so if you find a
that
one, then you do the search again.
Yeah, I do the search again. And then,
Okay.
because I was allowed to start the search, I add the Iceland variable by one. So after the second search, it will be 2 Iceland variable.
So if you find another one, then you increment by 1.
Yeah, right.
Okay.
Then I start iterating the cells again, and I will not be allowed to start the search because they are all visited or 0, and until I made the cell.
Okay. It's a great solution, and that's called it's also called DFS. Does anyone have any other? How would you approach this? So the other general way of thinking about it would be BFS, which is, I just wrote DFS, but it doesn't have to be DFS. Let's say you start here, then you can add both, check both surrounding areas, then check all the surrounding areas again, and then check all the surrounding areas here. And if it's 0, then you don't keep on going, but you can also do it in this way. So, so you can keep on going outwards, and that would be breadth first search. Whereas what Sunho mentioned about going here, and then maybe it's easier to see with the first example. So let's say the first direction you check is going to the right in this direction, then maybe you keep on going right, and then you hit something else, come back, and then the most recent one, you start searching from the most recent one again. That would be called DFS. Whereas BFS, you start here and then go here. The most recent one, you don't go straight to. This first one, you just complete, and then market is done. So you start here and then add both of these to a queue, and then you move on to the next one, the thing that's in the front of the queue. So BFS looks at every surrounding vertex and slowly expands outwards. And then DFS looks as far as possible, and then you backtrack. So you hit a 0, right? And then so you backtrack, you go find the next thing, and then these don't work. So this is done. This is done now. And then this can't go anywhere else. This is done. So you keep on going farther, and then you come back, and then you go here. This, maybe you go down, you go left. And then after you finish those, then this finishes or something like that. And then the last vertex that finishes is the first one. So that's what happens in DFS. And this is pseudocode, but if you do it in like a binary tree, then BFS maybe looks something closer like this, where you kind of expand outwards. So you add the elements that are connected to one. The order in which you search is this way, but let's say one's connected to 2. So yeah, maybe just read the pseudocode first, and then so BFS, you create a queue and then mark the visiting node as visited, and then while the queue isn't empty, add the starting node to the queue, and then pop or dequeue the front of the queue, and you get the current node from that. And for every connected node to that front node, if it's visited already, continue. If it hasn't been visited already, then mark it as visited, and then add the connected node to the queue. So add it to the queue, and then we're done with that, the first one. So if you look at this, so here 1 is connected to 2 and 3, and then you add both, to the queue. And well, first you add 1, the starting node, to the queue, and then you mark it as visited. And then you add 2 and 3 to the queue. You visit 1 at the very start, that's the starting node. And then you pop 1, and then the ones that are connected to 1 are 2 and 3. You add those to the queue, mark those as visited, and then queue 1 is done. So 1's been popped off the queue. Then you start at 2, 2 goes to 4 and 5. So you add those to the queue, and it's a queue, so those will be visited later. And then you go to 3, add 6 and 7, and then you go to 4, and then you add 8 and 9. You go to 5, add 10 and 11, stuff like that. So it kind of works in that way. Yeah, but it expands outwards, and you just add every node that's connected in the adjacency list if it hasn't been visited yet. So again, if you look at like the islands thing, then maybe you start here, and then the connected nodes, this is in a grid form. Connected might be defined by being cardinally in one of the 4 cardinal directions, being up, right, left, down, connected in one of the 4 directions. Then you might call that connected, and you could call that like an edge. So in a graph, you might have explicit edges, but in a grid, you have implicit edges. So you have a lot more edges in a grid than a graph. So a grid would be a type of a graph, but yeah, hopefully that's not too confusing. But okay. You can use disjoint set union, merge elements which are in the same set. Yeah, actually not super familiar with disjoint set union, but DFS, BFS are way more common. But yeah, might be able to use that. And connected components on a graph. Okay. Yeah. And everything that can work on a graph can be used on a grid because of the implicit edges. So, but it might be easier to start with grids. Yeah. So hopefully that makes sense. Based on this, maybe do you want to try writing code, or want to talk about probably best thing to do is just write code for this. This is probably one of the more basic ways, more basic problems for this. So it's important to be able to do this. So yeah, maybe just take some time and do this problem and pick BFS or DFS. The implementations are similar. If you've done it before, then maybe try writing it both ways, but you can pick one or the other to start with. I forgot to record, but yeah, I definitely recommend going to every direction, kind of like this. You can mess with it for every specific implementation, but I check directions like this. It's easy to read, I think, compared to like doing each direction defined like this. Is an old code from 10 months ago, I guess. And for BFS, you just do it within the loop. You do a BFS, you have a queue. I'm using a deck, but a double-ended queue can also be used as a regular queue. So push back, pop front, and this is looking in every direction. So basically the exact same thing going on here, except it's within here. And instead of doing DFS here, you're just adding to the queue. So that's pretty much the only difference. And yeah, that's about the only thing that's different. And so what kind of problems can you solve using BFS and DFS? You can figure out whether a path through a grid or graph exists. You can define it in a stricter way. What if you start at A and end at B? How many paths are there? Things like that. There are things, what's the shortest path? What's the longest path in a directed graph or something? Or can you generate a path? Or can you do a bunch of stuff? So there's a lot of ways to use BFS DFS. This is another example of flood fill, or it's like category of problems where you just search through the thing. Order doesn't matter. You're not doing a lot of special operations. It's the same thing as this first problem. So if you've done that, maybe you'll probably be able to do this. So maybe give this a try. And then the other application is going to be BFS unweighted single source shortest path. So let's say each edge weight is 1, then you can go through a graph, and let's say it takes one unit to move from one square to a square that's directly close to it. Then this is distance 5. The minimum distance is distance 5. You can also define like you can't go through here, things like that. So you might have like some kind of obstacle course, or you might have some kind of grid and then have obstacles, and then what's the shortest path? Can you go there? That's a pretty common thing that you have to do with BFS. And this is in 8 directions. So I'll hide it. This looks in all cardinal directions. So 8 directionally connected grid. So pretty much the same thing. And then this also has a pretty cool twist. So this is BFS in 3 dimensions. So you're given like different floors, and then you have DFS, but you have to go up and down as well. And yeah, that's pretty cool. I haven't done this problem yet. Maybe. Otherwise, you can use it to create patterns. DFS, you can create patterns with it. You can, we talked about this a little bit last time, but you can create patterns with it. And then Dijkstra's is for weighted single source shortest path, which means, let's say it takes like a set amount of units to move from one to another, then you might use BFS. But if it takes maybe like 5 to get from A to B, but it takes like 2 to get from A to C, and these are connected in different ways, then if the edge weights are different, then you might want to use Dijkstra's, but Dijkstra's is only for positive or non-negative weighted edges. So that's important to know. And otherwise, you have to do Bellman-Ford. I don't think you have to use Bellman-Ford in competitive programming, but maybe in the back of your mind, just remember that there are algorithms for finding negative as well, and those are based off of BFS. So Dijkstra's is very similar to BFS as well, and there's like this kind of goes through Dijkstra's a little bit. So I'm gonna pause and ask, like, what do you want to talk about? What do you want to work on? I should probably have said that in the recording. So Dungeon Master, it seems like you just do it in 3 directions, and then have to add another direction, but for the most part, not too different from other BFS. But maybe try out some of these problems. There's quite a few problems here, and try using DFS BFS where you might not have before. So for example, 2 to the n, you can use bit brute force. So you can use binary numbers to generate 2 to the n patterns. For n factorial time, you can use like next permutation. That's a really useful thing in C++, so that might be one way to do it, but being able to write it in DFS form as well is really useful, so I would encourage that. And then Dijkstra, yeah, it's pretty much like BFS, but with some additional steps, and then maybe use a priority queue or a set or something like that. So yeah, priority queue. And then a topological sort is also something you should probably check out related to DFS. It's a lot easier than, it's not too difficult. So just mark stuff as visited once, and then you just go through stuff once. So it's a little bit simpler, I'd say. And that's about it. If you have any questions or want to go over one of the specific topics, this is really kind of sparse, and it's just like throwing a bunch of problems at you. And honestly, the best way to improve, I think, is just to solve a bunch of problems. Like the first time you solve a new type of problem, I think you pretty much have to copy some kind of solution. You have to learn about it. You have to copy pseudocode. You have to copy someone's code. But after you get used to writing it, then you can start to think about, what is this code doing, and can I rewrite it, and can I implement it in a different way, or like, what does this actually mean, and how can I use it in a different way? So a bunch of difficult problems are built on existing stuff. So stuff like longest path from point A to point B, you can't do it with just regular topological sort. You have to like modify parts of it and things like that. So it seems like you have to learn about these concepts and then kind of internalize it. So be able to do the basic problem, be able to do the problem that just requires you to copy paste the BFS code, right? DFS code or whatever. And then you start to have to do more work on top of that. So for example, this flood fill is honestly like really simple, and it's just regular BFS, regular DFS. But for fountain, this you have to write your own code for this. This is not really applicable to other things. So I kind of messed up the order in the previous week. I put fountain first, but probably better to do fountain after. It's a good way of testing, like if you understand the concept. Fountain is probably easy enough. Plus, it's really good. So, and then a lot of these problems, they're not, they're usually going to have some kind of twist. So you have to watch out for that. It's not going to be just a knowledge check, or can you Google this topic or something, right? So the goal is to be able to work on problems that work off of the concept, and then change it in a different way. So that's the next step. So you have to be pretty solid with a lot of concepts, and then the difficult version pops up. So the versions where they just throw the concept at you are the easy problems. So, but you do have to start with those first, and you're not gonna reinvent the wheel. You don't have to try to, I think. So I don't think it, yeah, if you don't grasp concepts immediately, or if you can't think up of these solutions that exist already, it's not a big deal, right? So that's my personal opinion, at least. Do you have any things you want to say, Jesse?
Yeah, I mean, keep practicing. That's the only real way to improve, right? So just one announcement I want to make is I sent an announcement earlier this week about the ICPC. So registrations are going to start pretty soon. I think this weekend probably, or if not, then next week probably. So there's a form on the announcement that I sent, and if you guys are interested in participating in ICPC and you haven't done that form yet, then can use it because it's going to help us to organize like ICPC, because we have to manage all of that with our advisor and stuff. And a lot of you guys have, the ones who did fill out the form, some of you have said that you don't have a team yet and you want some help finding a team. So I just opened up a chat room in our server called ICPC Group Finding, and I'm just gonna post a message in there. So you guys can use that to find groups, but you can also just DM each other. And I can also like see like which of you are interested in which divisions, and then maybe try to get you in touch directly that way. So yeah, we're gonna try to make sure that everyone who wants to participate can participate, because we need to get into groups of 3. All right.
How many divisions were there?
There's 2 divisions. So division 2 is like kind of like a practice division. It's not really like the official competition. Division 1 is like the actual competition that goes to the world finals. But it's obviously a lot more difficult.
Is it possible to enter Division 1 and Division 2 at the same time?
No, you have to be in one or the other.
One or the other? All right.
Yeah.
Yeah, maybe try out some of the past problems. And yeah, even Division 2 is like really hard. Like half the Division 2s are brute force problems, and then those get modified to other stuff for Division 1, but the other half are still really hard problems for Division 2.
Yeah, we'll probably start looking at actual ICPC problems from the past soon. Maybe as soon as next week, because we're gonna start we want to get used to the format of like reading those problems.
Yeah.
All right, that's it for me.